Okay, YouTube, this is my last video on graphing equations, and it's kind of just a tribute to using linear models, essentially. And a lot of the times we'll say line graphs, such as the one you see here. And as a matter of fact, we'll just go ahead and take a look at what this says, and then I'll talk about how I'm relating this to my previous videos. But it says that divorce rates are considerably higher for couples who marry in their teens. This is a shocker, I'm sure, but it says that the line graphs that you see here basically show the percentages of marriage ending in divorce based on the wife's age in marriage. So you can see this here. We have two different situations. We say if the wife is under age 18, you can see that as the number of years after marrying goes by here, and we have some graph that goes from like 0 to 15 years after being married, if they married under 18, you can see that it's really high up here in this percentage of marriage ending in divorce. Okay, so it like grows very quickly and kind of declines. I mean, I guess if you make it to 15 years of marriage, you're less likely to get divorced. But it does say that if you're under 18 and you've been married for 15 years, of all those people, about 60% end in divorce. But you can see that we have some under 18 curve here, and it's not exactly linear. And we have, if the wife is over age 25, the divorce rate. So basically, you can see that it's higher if you get married in your teenage years. Well, what you can see over here, we have two models that basically approximate this data. And again, a big, kind of focus of this math class is that we have data, but we use equations to kind of model situations that they approximate it, okay? They don't tell exactly what's going to happen. But we have a model here. It says if the wife is under age 18 at the time of marriage, we have D and N, where we have N is the number of years after marriage. That's given to us here. We say D represents the percentage of marriages that end in divorce, okay? So we have the percentage as the number of years goes by if you're under 18 when you're married, or if you're over 25 at the time of marriage here, okay? So these three things I want to do here. It says use the appropriate formula from example 6 to determine the percentage of marriage that end in divorce after 15 years if the wife is under age 18 at the time of marriage, okay? And then this one says use the appropriate line graph to determine the percentage of marriage ending in divorce after 15 years when the wife is under 18 at the time of marriage. So basically, the difference between these two situations is this top one says here, use the appropriate formula. And this one says use the appropriate graph. Okay, and so that's what I want to look at here. So in terms of what formula should we use, well, this says, the number of marriages ending in divorce after 15 years. So we're given some N value here, and we're asked to find the percentage of marriages ending in divorce. So basically what we're saying is, what do we know about D given the N in the first place, okay? So we have one, and we need to go find the other. And it says that we want to use the model for wives being married under the age of 18 at the time of marriage. So that would be this first model we see here. And in terms of using the model, what this means is we're just going to go plug in what we know and go find what we don't know. And you'll notice that I've put in a blank set of parentheses for our N here because that was the data point that we were given. We say, well, if this is 15, then what would be the percentage of marriages? So we can go ahead and calculate this here. We say 4 15s is really 60 plus 5 more. We would say 65%, okay? 65% of those people who were under 18 when they married and have been married for 15 years, 65% of those people will be divorced, okay? So according to our model, this is what we get here. What we want to do now is we say, well, now let's go use the line graph. Let's actually look at the chart. So in terms of using the chart, we're doing the same process here, except for we're looking at where N is equal to 15. And I notice that that's here. We just need to trace it up to the appropriate model. So really what we're saying is if I were to know that N is 15, we could actually trace this up to our graph here and then trace it over. And we could say, well, what does this tell us about the percentage of marriages here? And when I look at the graph, okay, we actually get 60%. So, I mean, it says, does the value given by the mathematical model underestimate or overestimate the actual percentage of marriages ending in divorce after 15 years shown by the graph? See, our model estimated 65%, where the graph, which actually showed the data, only supported 60%. So we would say that this overestimated, by 5%. So about the only other thing I want to do is look at how these models kind of stack up against the actual data chart over here. So what I've done is I've actually went in and I put these models into my graphing calculator. And you'll notice I'll turn these graphs back on here. But we have 4x plus 5, y equals 4x plus 5. I can't put in d's and n's. So we're going to have to say, well, our dependent variable, which is the percentage of marriages here, is equal to 4 times x plus 5, where, you know, n is the independent variable, the number of years. So I put both of these in. I'm going to go ahead and hit graph, and I'll go ahead and put this over here. The thing is, it's hard to do a straight up comparison because right now our window is going from -10 to 10, -10 to 10, and going by ones. So let's go ahead and modify our window here and cause this to say we'll start at year 0. Okay, our x min is 0 and our x max is 15, and it seems to me that they're going by a scale of 5. So we'll change our scale to 5. And then our y-axis here goes from 0 to 70, and it looks like they're going by 5. So we say 0 is our x min, or y min, and we say 70 is our y max, and we're going to go by a scale of 5. So I'll type in a 5 here, and then I'll hit graph. And what you're going to see is something that's very, very similar. I'm trying to get this really close here to what you see over here, but just remembering that this is an approximation. So to go back and answer this question again, we say, well, using this first model here, which is the wife was under 18 when she was married, you know, as the time goes by, you know, what would be the value of the percentage of marriages dissolved at that number of years? We could actually either go look at the graph here by using, say, a trace key. I could hit trace and sketch over to it, you know, kind of hold down on this and go over and try to approximate, or we could go into our table. So really quickly, our table here, let's go ahead and start our table not at year -3, which would be off the data graph here, but we'll start at year 0, possibly. And I'm going to hit table, and what you're going to see are, given the years here, these are the percentages of marriages that are dissolving. And so this Y1, remember Y1 here was for wives under age 18. I'm going to go back and look at this. We say 4x plus 5, okay? So that's our Y1 outputs under 18 when they're married, and this is over 25 when they're married. So you notice that this doesn't go down to 15 right now. We could go to table set though, and if we go to table set start at 15, we could say go back to our table. We got the same data output we did by plugging this in by hand. So we can actually use a table, okay? And again, if you don't want to go to table set, here's one thing you could do. You can actually just scroll up or down, and it'll scroll through the data values for you. Cheers.